All right, class, dual credit, college algebra. Here is your 5-5 lecture. I can't actually see what the video is showing in terms of like my camera and the screen, so hopefully everything works out fine. I apologize if any like slide titles or anything get messed up. So this is your last lecture of the semester. So we are talking about systems of inequalities. So chapter 5 has all been about systems of equations. So now with inequalities, then we're talking about those less than, greater than, less than or equal to, greater than or equal to those. So how do those interact with systems of equations? How do we stick multiples together? So first, we're just going to do a quick recap of how to graph inequalities in general, which, believe it or not, we haven't done that yet in the book. And then we'll stick multiple graphs together. So how do you graph a linear inequality? You want to change into linear form, and what I mean by that, just be sure you can graph the line. Typically, it's going to be y equals mx plus b. So that way you can find the intercept, you can find the slope, and you can follow. Remember, you only need 2 points to make a line. And then go ahead and graph the line. The new thing here with inequalities is that depending on whether you have the equal to underneath or you don't, it's going to change whether you have a dotted line or a solid line, because coordinate points on the actual line could be included in the solution or not. So solid line, if you have the or equal to portion, use a dotted line when you follow your slope and intercept if you have just greater than or less than. Now, when you do that, you also, every coordinate point above or below the line could also be a solution to your system. So for me, I say for number 2, choose a test point. Just try to plug in a number from your coordinate plane. Replace x and y with just any number that is in 1/2 of the grid and see if it's true. So here's an example. 2x minus 3y equals 6. So here we want to know what the line looks like, so I'd like to solve it for mx plus b so I can graph. So here what I want to do is solve for y. So we'll subtract the 2x over to the right side, and then we'll divide the whole thing by -3. Now we are dividing by a negative on an inequality, so the sign's going to flip. We have 2/3 x minus 2. Now because of this, we have a solid line. So we're going to graph this like normal, start at -2, and then we're going to go up 2 over 3, up 2 over 3, and we could keep going, but it does not need to be super accurate. So that would have been the end of the problem if it were just an equation, if it were just equal to, but now we have to figure out, do you shade above or below? Because every coordinate point above or below, we have to figure out which one. Everything could fit the inequality because we have an infinite number of solutions. So what I do is I'm just going to pick something. Now, some of your algebra teachers probably taught you that less than means below and greater than means above. But this isn't super reliable, mostly due to the fact that depending on if you have something that has a really, really steep slope, or depending on if your y is on the right-hand side of the equation, this all gets kind of thrown out the window. So the safer way to do this, and it doesn't matter where your y is, it doesn't matter how your equation is set up, just pick a random coordinate point. So I'm going to pick this. I'm going to pick 0, 0. And I'm going to try plugging this into the original problem to see if the inequality holds true or not. So if I do that, I get 2 times 0 minus 3 times 0. Is that bigger than or equal to 6? And here, this is not, right? 0 is not bigger than 6. So the place where I put 0, 0, that half, that entire half, nothing in the top half works. So we're just going to do a quick shade of everything underneath. And on MyLab, it's just a little paint bucket icon. You're going to shade everything underneath. It'll just highlight it all in yellow. All right, for the second one, it's already in linear form, intercept of 0. And now we're going down 2, right 3. But here we have a dotted line. So down 2 over 3. Again, remember, you're just clicking a bunch of stuff in boxes, so you're not having to draw by hand. And then now above or below, we can't use 0, 0 as our test point here, so I'm going to pick something. I try to stick with 0 and 1 if I can, right? They're the easiest numbers to plug in. Let's try plugging in 1, 1 into this problem. Is 1 bigger than -2/3 times 1? Yeah, it is. 1 is bigger than a negative number. So this one does check out. So I picked a point that was in the correct half of the graph. So I'm going to shade all of that. And so there's two parts of this problem. First of all, figure out what the line looks like. Do you have a dotted or a solid line? And then what half of the grid do you shade? Obviously, I would ask for questions here, but y'all aren't here, so email me if you have questions. Graphing a nonlinear. So we just talked about this in the 5-4 lecture that y'all saw on Friday. So x squared plus y squared less than or equal to 9. The question that commonly comes up with students is, well, if we're not doing lines, what else are we responsible for? So let me just make a list. So what should I graph? Or be able to graph, I guess I should have said. What should I graph? So lines, parabolas, so x squareds, and circles are the only things covered, that anything that I included on your homework that I would include on the test. So remember, this is just y equals x, this is x squared, this is x squared and y squared. So here we have a circle, and this is from lecture 2.8, if you need a refresher on circle stuff. So this has a center of 0, 0. It's got a radius of 3, and it is a solid line. So pick a few, and solid line circle right here. Let's see if I can make this look somewhat decent. There we go. But now, just like before, we have shading that we need to do. So we need to shade, there's no above or below. So here we're going to have inside or outside the circle. So why don't we try plugging in 0, 0 into the inequality. So we get 0 squared plus 0 squared. Is that less than or equal to 9? That one does check out. So we are shading inside of the circle here. Those are the only two areas that we would have of our grid. System of linear inequality. So this is kind of the main idea. This is everything that we're supposed to do, what the book wanted you to do by the end of this. So now we're just going to stick two lines on the same grid. And instead of just shading above or below, you've got to figure out which region of the coordinate grid that you're going to shade. So you're going to graph both lines. And only one of the areas is going to work, so you've got to figure out which area. So let's rewrite both of these. So here we've got negative y less than negative x plus 1. So y is bigger than x minus 1. So there's line number 1. Let's redo this one. 3y greater than or equal to negative 2x plus 12. Divide 3. Y greater than or equal to negative 2/3 x plus 4. So there's my two lines. This one is dotted. This one is solid. So you have a mix of both. And on MyLab, you're just going to click a little, you've done this before. Click the little solid or dotted line thing on the graphing tool. So let's graph the dotted one. Intercept of negative 1, slope of 1. There we are. Oh, shoot. Almost a straight line. Okay, and then negative 2/3 x plus 4. So down 2 over 3. We're going to do a solid line for that one. So notice how we've created different regions. So, here, 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 here. So which one do I want to shade? Again, pick a random, and here you can't just automatically eliminate one whenever you don't figure out what works. You can try to do some combination of above and below if you're comfortable with that. So technically we want to be above the dotted line and above the solid line. So that would be somewhere over here. Now let's double check to make sure it works. Let's plug in a coordinate point from somewhere in there. It doesn't matter. Let's pick like 0, 10. That's pretty definitively in that top center region. So I need to plug 0, 10 into both of these. So test. So I'm going to test 0, 10. Is 0 minus 10 less than 1? Check. Is 2 times 0 plus 3 times 10 bigger than 12? Yeah, so 30 is bigger than 12. Check. So this was the correct region. Okay. So system of inequalities, I think we may be done. Yeah, we're going to be done after this. So here's our last problem. Now we have a parabola with a line. So again, the nonlinear stuff that you may be responsible for in chapter 5. So here's a parabola. Let's go ahead and rewrite the line while we're working this. So negative y greater than or equal to negative x plus 2. Divide everything by negative, so the sign's going to flip, x minus 2. All right, so we've got a parabola shifted down 4, and we've got a linear function. They're both solid. So let's try to make this somewhat nice. And then we've got a parabola shifted down 4. So we'll do our parabola points from here. So we actually have quite a few different points to work with here. We got a few regions here, right? We got this region, this one, this way down here, all this, and then we have the tiny one in here. Now, as far as which one to test, we want to be above the parabola but below the line. So I'm thinking it may be this tiny, tiny region down here. So this is the only like whole number coordinate point I can mess with, 0, negative 4. Oh, sorry, that's 0, negative 3. Erase. Make it look nice for the notes, right? 0, negative 3. So let's plug that into here to see if it works. So test 0, negative 3. Does that point work for both of these? So negative 3, is that bigger than or equal to 0 squared minus 4? And yes, negative 3 is bigger than negative 4. Remember, greater than would be more positive. And then for the second one, 0 minus negative 3, is that greater than or equal to 2? Yes, so it actually is that tiny little sliver in between. There you go, that's it. So for those of you that are getting a head start on your homework and doing this over Thanksgiving break, good job. You're going to be well prepared for the exam. For those of you that want to take a look at this later on, you have this video now, and please email me or let me know in class if you need any help on any of the assignments. So that is it. Have an awesome Thanksgiving. I will see you later.